Okay, students, welcome to week number 9. Today we are going to cover the topic of cloud computing and mobile technologies. So last week we covered the topic of physical layer, and these are the topics which we covered last week. So just want to recap quickly how many number of layers we have learned in networking model. 5. What are those? Application. No, go in order. Go in order. What is application? First application, then application, and then second one, transport, network, data link, and then physical. Okay. So remember that every layer has its own some key points which you need to grip it in your mind. And you have seen in your midterm test as well, that was there, that thing was very much there. If you are clear with that, who's on the last one? Please come. Okay, so that's important for you to see all those things, and remember that it's easy to remember. As I mentioned you last time, how to remember it: when you open your computer, what you open first? Application. When you run any browser, where you want to make it running, transport it. You transport it on where? On network layer. And then data link is the thing which you need to remember, and the last one is physical. Then it's easier way to memorize it. And if you see your Wireshark, in that one as well, that's in the same one. Have you noticed that in Wireshark? Just quickly want to show you one thing. If you go to any packets of Wireshark, which we opened last week or something like that, for example, see this one, TCP. TCP is a transport network, data link, and that's a whole frame. Then of course it's going on physical, but this is, you can see this is in order as well. If there is some package which is about the browser, now you can see that UDP, again UDP is a TCP one, internet protocol, data link, and then frame itself, which includes that data link. And these are the on applications. These are applications. So it's you can see that in that one it's the same order. It also follows that order. You can see that again TCP, IP, data link, in the same way it's going on. So application layer and physical are two extremes of that. So last week we have learned about that physical layer, how our actually data is transmitted and over the transmission media, which includes twisted pair, coaxial cable, optical fiber. What else? Terrestrial microwave. What else? Remember that? Satellite, infrared. So these are all different ways to communicate your data, to send your data over from one point to another point. And we know that it is about multiplexing. The time division, when we are sending a data, we need some rules and regulation to send. Either we use time division multiplexing, either use FDM or WDM. And also we have learned about, like, when we are doing that communication, either is it in simplex, half duplex, and full duplex communication. This week we are going to look toward two different areas, which actually definitely you will in your future courses you will have a look more in detail as well. So that is about your cloud computing and mobile computing. So these two things we will just touch today with the very basic ideas of that, what is that about. But in your upcoming courses you have two courses on that subject. One is on cloud computing, which is ITECH1100, and one is on mobile computing networking, which is 2300. And in that one, you will go in more in depth of those things. Do we have a duster? Okay, anyhow. So let's start with the definition of, first of all, cloud computing. So with the cloud computing thing, if we see that, what is the definition? The practice of using a network of remote virtual servers that are hosted on the internet to store, manage, and process data rather than a local server or a personal computer. So if we go back in 2010 or 5, whenever we want to uh, do anything on computer, we need to buy by ourselves. We go to the market, purchase with the specification. We see, okay, this RAM, much RAM I need, this much hard disk I need, this much the processor speed I need. So we built in our by ourselves, and then we, if we want to play a game or install a software like Microsoft Office, we need to buy a CD, put it in that, and then use it. But now 80 to 90% things are going not on our computer, somewhere else. We are just through the internet accessing them. It means that we are remotely accessing those all applications or games or softwares without having installation on our own system sometime. And it means like virtually we are enabling us to use everything over the internet. And like in upcoming years, this thing will be keep increasing on. Just want to recap you one thing, like when in our times, like from I did my bachelor's in 2003 to 2007 time in telecommunication. At that time, the most of the things were at the stage of where mobile phone was just the touch on the normal one, simple one with the button ones. There is no concept of touch, or there is no concept of smartphones, and there is no concept of thinking of that like we are able to make a call or video call, because there is no screen of that. And just going more back on that, in 1964, there is a first time. Before that, like people were using a very rarely, sometime, somewhere, using the landline phones to communicate with each other. But that was really rare. But at that time, some people in 1964 in the conference proposed that there will be a time comes when people will walk and talk at the same time. And people were laughing at that time on those. So it is just a matter of 50, 60 years. So you can see that how things have been changed. So what lesson we learned from that story? The lesson is that now you're sitting today in 2023. Definitely there are hundred of things are there on that which you can think, which maybe looks like something funny, but would be an innovation of for the new century or for the next 50 years. That's the first thing. Second thing is that due to the evolution of internet, high speed internet with the high data rate, with the more maturity of telecommunication services, high data rate. Before 2010, there is a concept of using YouTube. Why? Because there is no enough speed to run it. So if we see today, let's say taking example of a Menulog or a Uber or a Airbnb, why they are so popular? Only due to the reason that hundred of different things are connected in a way that which helps to do that thing. For example, if there is no Google Maps, there is no internet, if the mobile phone doesn't have that much capacity to take that much data, run smoothly, there is no runtime GPS location in mobile phone, your mobile phone circuit electronics is not capable enough to handle that much processing. So it means that those Uber, those services would never be a possible in today's life. So what is the second lesson from that? Now onward, for you people, you are in this stage. The stage is set for you. We already passed that. In our time, telecommunication was just evolving. So for us, learning about GSM, 3G, 4G at that stage was very good, and a lot of infrastructure regarding the antennas, establishing with the towers, putting the systems on, mobile towers establishment, and those all things were there at that time. And there's a lot of jobs in that. That's why. But now things are changed based on that's now already matured. 80%, 90% those towers are already established. Maybe there is new places, of course there is always going on, but not at that level. But now the things are more on top of that. What are those? For example, a high data rate is there, your communication is so fast. Actually, as I mentioned, 10 years back, 15 years back, you have to use a CD-ROM to put something on your own computer to run that. Now you are using somewhere which is that server is in USA or UK or Norway. You are using on your own computer that software without any delays. So that much the system has been improved over a period of last 7-8 years, especially. So for you people, cloud computing is one of the major field which will be keep on going on, will be increasing. Now see the example from the other perspective. As you know, I would say that the decade of 2010 to 2020 was more for the websites, whereas from the onward, from 2020 to onward, next 10-15 years, it would be more like the apps, and maybe more than that. There is some maybe a next level coming up as well. We never know after the apps. And what is that in that thing is like it's more swift, more quick, more easy to use. Why we prefer app rather than website? Because apps has straightforward clicks to reach to your destination. Website is for more details when you need it. So for example, the kids who are in the age of 6 or 7 years today, who are very much well aware of the apps, but they don't know what are the websites. So next 10 years, they will be on 15, 17, 18 years. For them, they don't say, what are the websites? We don't know. We don't know only apps. So it means that for you people to work in on apps is much more, or the cloud development things, or those things are very important. Because your market is those kids which are coming in next 10 years. Eventually, whatsoever we say, oh, technology has this much type of good things or bad things, that's a separate thing. But eventually the market will move in that direction. Either you or either someone else will take advantage of that thing. But this is how the market moves on, with the flow of the things. They know that how kids are using this stuff, they have the data, they can see the things, and based on that it is keep moving on. So for you people, you need to understand that when we are learning those subjects, they actually had a very major impact on your career, and your career should be based on your own thinking. Like as I gave you the lot of directions from there, from which perspective you can think and make your decisions. So as I mentioned, with the cloud we are coming toward. Now it's not just a metaphor for the internet. We know that it is just as a symbol we use it, the word cloud. So in cloud computing, we are using computing resources made available by a third party. These resources are hosted on the internet. Okay, the third party is actually doing for you everything for you. You are just using those services. So we actually classify that thing into different parts. Let's see what are those. First one is infrastructure as a service. Infrastructure as a service. Okay, can you read that slide?
The cloud provider manages all hardware, including servers, storage, and networking components. The organization is responsible for all software, including the operating systems, applications, and associated data. The organization is also responsible for virtualization software as required. Such architectures have the advantage that the organization no longer has the responsibility of providing hardware associated air conditioning of server rooms, power supply issues, and associated uninterrupted power backup systems.
Yeah. So we can see that when we are talking about the word infrastructure, so it's more like a physical hardware stuff. Like your hardware includes servers, storage, hard disks, networking components. So these one are managed by the third party. Like you are not going to buy those things, but you are using them from those companies, and they will charge for you for those services. So what, as an organization, or let's say ATMC, don't want to spend money on buying the computers, hardware, storages, or those things. Rather, they say, okay, we need some organization which just we can hire them and we use their services and put our own operating system on that. So when you put your own operating system, your virtualization softwares, and all the things are basically done by us, that means that is infrastructure. The all responsibilities regarding how to make function of those network devices, make it cooler in the server rooms, electricity cost, that is by the third party. You are just using those devices to put your operating system to use them. Okay. So next one is platform as a service. Okay, can you read that? Okay, put this one together.
The cloud provider offers the hardware, the operating system, and base database or other software. The organization's programmers can code database or other applications in any language they like. They also have control over their own data. PaaS, PaaS, is not restricted to database infrastructure. This allows the organization to build their own custom applications without the need to worry about the operating system, database system, or hardware.
Yeah, so in this one, if we talk about, it's about now platform. Platform is the next level. You already have a hardware. Now we, on top of that, we are putting the operating system. So the operating system is your platform. That could be a Linux, could be a Windows server, Apache, no, not Varsha. Main your Linux system, operating system, which is you need to load, just put it there, which you need to put it there to uh, use other programs. Yeah. Okay, like the way how you installed the VirtualBox, and in VirtualBox you have to put operating system to run that as a separate thing. So in that one, hardware is given and operating system with the database things are given as well. And whereas the organization now in that model, the provider of the third party, which is the cloud provider, will handle your operating system as well, also handle your what? Your hardware as well. You're just using your own program, downloading it, putting it to use them, and sometimes the database is also given by them. So the organizations such as Federation University, ATMC can custom their own applications on it, run it, and they can use all of them. Okay. So this is how it is working on with the platform as a service. Third one is software as a service. Give to him to. Yeah. Okay, read this one. Just maybe here is fine as well. It will be okay.
Software as a service. Here, the cloud provider provides everything, including the software. Users access the software from the internet and are able to
Guys.
customize their user interface. Commonly, email is outsourced by organizations to cloud providers.
So now there is a third stage. In that third stage, all of the three things are outsourced. Your what was the top level? Hardware, operating system, and on top of that, you are now telling them, okay, application you should handle as well. For example, email. The email of ATMC or Federation University is basically already by the Outlook, Microsoft. So it means that they just outsource that email one. They don't have their own server. They ask Outlook to, we will pay you this much money and you should give us your resources to use your things. That is used as a software as a service. So basically, now softwares, everything is installed, systems are ready, you're going to use it as a customer. Okay. For example, you're playing online games. So those games already are on the server somewhere in the world. You are just logging in as a user. You are just using them. All the three things are there. Maybe they are earning money by advertising something, or they are charging you per month some charges for using those games, or for whatsoever. It depends. But mainly, what they are doing, their complete package they are giving to you, and based on that, as you go up, they charge you more. For example, if it's on hardware, you have less charges. Your hardware plus software, the operating system, more charges. Applications, more charges. So there are three main things what we have learned. First one is infrastructure. Second is, what was the second thing? P. What is P mean?
Pass.
How you run the applications? What you need? What you need to run applications? Infrastructure is the first one, which is the hardware. Then how to run that hardware? What you need? Software is the last part. Before software, there is in between something. What is that? When you buy a new computer, what you need to put it in that to run it? Operating system. Operating system, Windows. If Windows is not there, operating system is not there, how you run it? You have a mobile phone. When you go buy a mobile phone, you open it first time, the operating system runs on it. Nowadays, the system things are very simple. Whenever you buy a laptop or a desktop or a mobile phone, all things are already installed. 10 years back, you have to do by yourself. So you remember that. Now the new generation, see, you don't need remember that. That's the thing. That's how it goes on. With the new generation, after 10 years, they will not remember that. Okay, oh, there is an operating system as well. They only know that. Oh, there is apps. We know apps only. So this is how the things evolved. So coming to the next thing, cloud storage services. So cloud storages are made available by many large players. We know that OneDrive, Dropbox, Google, Apple. So what they are doing, they are giving you the services, ready-made ones. You are using them to store your data, and also we have some free storage available, or extra storage, or extra subscription you need to buy to do that. And also, depending on your services, you get file storage. You get synchronization. Synchronization means, like, for example, if you have on my mobile phone, I have put the app of Dropbox. On my home computer, I put the Dropbox. Whatever the file I'm putting it, it is synchronized. So you can, without any delay, you can access it. And yeah, so and also with the tablets, with the phones, whatsoever it is. With the Uni Cloud servers, if we see the services with the Fed University has 100 of services running on cloud or local or cloud servers. Some are local, which are totally, purely handled by them. Some are on cloud, which are partially handled by them. But again, we need to classify in three different parts. What are those parts? Infrastructure, remember that please. Infrastructure, platform, software. Because first one was IaaS, PaaS, SaaS. Infrastructure, platform, software. Okay? It's simple. Like whenever you want to run a computer, what you need? You need infrastructure. For infrastructure, what you need to put in? Platform. And for on platform, what you put it on? Software. Simple. See, things are, whatsoever the study you do in the life, the people who are working in that area, they put the things in some order. But we try to memorize it. Rather, we want to find out the symmetry. Then it is like easy to remember in your mind as a story. So then it makes sense. So what we are saying is, until recently, most services were based on servers at one or other or campuses or at the IBM data centers. So some of the servers are at campuses, which is purely run by the federation or by IBM data center. These local servers are maintained, upgraded, backed up, patched by Fed University staff. So it means that, like, for the services, for the hardware is for someone, but operating system, putting updates, running those servers, they're done by themselves. But maybe the hardware is not with them. That is with maybe with the IBM. So the local servers, what they have, we have around 85 servers hosted at various Fed University campuses. So with their own campuses, what the servers they have, it means they purely their own product, where they have their hardware as well, their platform as well, their infrastructure as well, or some with the IBM. Oh, so these are all almost all running VMware virtual machine softwares. Combined, they are around 500 guests, like 60% Microsoft platform, 40% Linux platform servers. Based on that, they are running their services, which includes email, which includes your security, which includes your website, different things on that. So number of guest servers only increase with respect to time. When as more number of students grows up, let's say like there is a company who just started 5 years ago, and they have total 50 customers. For them, maybe they need one server at home to run it or to put all things in place. But eventually that company suddenly grow up from 550 customers to 10,000. Now there are two options. Either they have to put more servers to handle all those requests, because with one server only you have a limit how many number of websites people can open it at the same time. Okay, and so therefore it's important, when you know that it's their demand is increased, based on that you increase the servers. So that's how the guest servers you can increase on that. Coming to the cloud part, now this cloud part is mostly, this is by the cloud service providers, they actually do that. Okay, can you read that one? Give to this mic to that guy. Read that. Just speak, it's okay, just put it there. It's fine.
Some services have been shifted to cloud service providers. A corporate website. The Fed Uni corporate website is hosted by a cloud provider, Amazon. The service is categorized as SaaS, software as a service. Our staff can add content, but the maintenance of the hardware, software patches, front and cache servers, backup, etc. are all handled by the cloud service provider or third party. We chose the web server platform, My Server Matrix.
Yeah, so in this one, if you can see, now most of the things are done by the third party, which is basically the Amazon, who is looking there over their website things. What they are doing as a Federation University people, they just do a basic tweaking of it, like to change minimum changing the website data, content or something, but most of the stuff is done by Amazon Cloud Services. And also if they have maintenance, anything, all handled by the cloud service company. And they choose the web server platform, My Server Matrix, to do that. Azure Cloud Services, remember that Google, Amazon, and Microsoft, they have their own cloud services, and also there are a lot of other companies as well. So Azure Cloud Services include Microsoft Cloud Platform. So Microsoft one is the Azure one. So Federal University also have many servers, around 30 hosting services, including workstation management, identity management, and some others. These services are an example of infrastructure as a service. What is mean by that? Like you are actually getting their systems only, and rest of the stuff is done by the university by itself. So we have a high-speed network linked to Azure to ensure fast access to the hosted services. So your services are hosted somewhere in the Azure network. It means that your your operating system is yours. You are only doing is take their systems, and on those one what you are running, your workstation management, your identity management. For example, when we log in, how it is going to check is it the right person or right password, where it is located. So all those things are done by again those servers. Google Cloud. Okay, can you read that?
A cloud platform from Google enables users to create business solutions using Google-provided modular web services, offers a wide array of services including large and PaaS solutions. With Google Cloud's multi-layered secure infrastructure, users can rest assured that anything built, created, coded, or stored can be protected. This is done through a commitment to transparency and highly trained team of engineers. Others, a variety of tools to ensure consistent performance and management. Offers a free 12-month trial, which includes $3,000 towards all services and products offered by Google Cloud Platform. Some online commenters have mentioned that setup can be difficult or for beginners.
Okay, so in this one, if you see from here, Google Cloud has their own services. They provide you like the way OneDrive is, but they are also providing you multi-layer things. What type of services you need? They can give you a different layer, like infrastructure one. User can rest assured that anything built, created, coded, or stored will be protected. So it means that you can code the programs as well. You can build it as well. So also according to related to the performance, you can run those systems. And there is a actually 12-month free trial. If you go on Google Cloud, you can sign in, and you can get 12-month free trial of that with $300, where you can actually build or click it on the server option. You can use their server, use their RAM, hard disk, make a system online, open it, go there, install any apps, do some work, and they will charge you based on how much time you are running it. Once you close it, when you go off, they will not charge you. So you can see that it's like that, you are pay as you go. How much you are using it, based on that you are being charged. And that's why I gave you example of that thing. Like as a company, when you actually going to for us, especially new entrepreneurs or the students who want to build a business or want to make an app. Let's say you have make an app on your own server, and you are now ready to make it public on a Play Store. With due to having a very innovative idea, maybe your that app grows up 5,000 people in 2 months. Rather, like you are going to buy 10 servers by yourself, you go on Google Cloud, hire those servers, put your data there, and just pay as you go per month. Maybe you'd never know that in next 6 months how the things goes. Rather, putting so much investment, you're just paying for rent. And once you know that okay, this is now more mature, then you can make a decision. It's a trade-off. Like if your number of customers are that much number, where you see that now cloud is much more worth it. Whereas on the other hand, if your number of users are not enough, then maybe you say, okay, my own management of stuff is more better to do that. Make sense? So this is how this all things works on. IBM Cloud. Similarly, IBM is more like you can say on a deep level, which includes the services as well, platform as a service, software as a service, infrastructure as a service. They give you all options. In IBM, actually, you can go there in their system, you can build the apps there. You have just the idea. You use their platform, use their applications, everything, connect it, run it, and then give the link to the Play Store to run my app. Now you are doing nothing. You are just building up the things and putting it on the Play Store to make it public, so people actually or promote it at the end of the day. That's your separate thing, which is marketing. Promote that. For example, you see sometime in our using of Facebook or different apps, when we scroll up and down, we can see there are some game sponsored things are coming. What are those? These are people idea. They make that game. They sponsor it. People see, oh, that's good game. Okay, I can play. So they are playing, but that's connected to the third party cloud. They have their idea of that game, and they are making money out of it. And from that money, they are paying to the third party, taking their own profit, and that's how this system goes on. And also, in your one of the subject in cloud computing, you will learn in future how to build and make apps in IBM cloud. So in IBM, hard servers are referred as a bare metal. That's another name of hard servers, hardware servers. Clients have sole access to the entire server, which greatly improves the performance. So, for example, they give you as a as an infrastructure, you have a complete access to the hardware. Whatsoever you want to make it, you can make it. For example, you need some special services. You don't need other ones. You can select only those ones to run. And also, you need web portal API interface to run the apps, and therefore it offers full customization. Everything that is including the server is hand picked by customer. For example, if you buy your own server, maybe some of these services are not used forever, so those resources are wasted. But in the cloud, you pick only those which you really needed. When you don't need it, put those servers off. You are not being charged. Let's say you know that in your app it is more busy in the morning time when the school hours are there, or in the time when there is a end time of school is there. Maybe your app is more about there is an app which actually connects teachers and parents to see like your kids is signing off or signing in. When you send your kids, you put an app sign in, teacher say accept, your kid is there in the class. Just an idea I'm giving you. So that's your idea. And similarly, you have an idea of like when that thing is like at the time of uh, going off from the school. Again, parent will open the app. They will say, teacher will open the app first. They say sign off the kid. Teacher says, the parent will say sign off. It means the kid is picked. So maybe in that type of app, you know that your app is used only for those peaks. So in that way, you can put your servers at that particular time on high, and other time you can say, oh, I don't need it. So this much flexibility you have. So you can see that how cloud will change the life in future. The thing is, because everything would be so connected to the internet, and it's like the services, like how you buy a petrol for some use it, finish, then again go it, fill it, use it, something like that. So you will see the things will be moving like that. So it's like a pay as you go options. And on their website they have a calculator as well. Let's say you need such services with this processor, so they will give you the amount, like this much you will be charged per month, or if you use them with respect to that.
Sir, actually, I have work at 3:30, so I need to leave now. Is there any possible?
3:30, but right now 2:30 is there.
Sorry.
Right now time is 2:30.
Yeah, I have to. It's like takes 1 hour to go, right?
Okay, you can go, but you have to then finish the lab part and the other things.
So, sir,
Okay.
sorry for that.
What's your name?
Yeah, MPC.
Okay. Okay, next you can read this slide. Next person.
Me,
Yes.
pros and cons, pros and cons of cloud services. The future of cloud. Deployment of new or enhanced service implementation. If a busy period is approaching, then add extra computer service then back to normal when the peak period subside. Example, enrollment time at trading. Fusion of limited resources, infinite resources. That employed technical staff on
Can you put the charging on in that?
cloud is underpinned by stable negative aspect of cloud.
No, no.
Cloud services comes at a cost. You pay for what you use. Cost depend on safety,
Yeah,
power,
yeah.
memory, time, and capacity. I/O, backup, and other aspects of the services you require.
Yeah, so these are some of the positive and negatives. What are the pros? Like we know that positive features include, as I mentioned, let's say Federation University has a in new enrollments or maybe on the exam time, your Federation University website is very busy. Maybe at that time they need more resources, so they hire the cloud services, use them. Once they don't need them, take them off. So you are only charged for that point, for moment, or for those days when you need those services. And also in illusion of infinite resources mean you have a feeling that, like, if you want to improve your services, you want to add more resources, you have a right now 1 terabyte hard disk, you want to make it 10 terabyte, no problem, because you can add up with more charge or more cost putting in, you can use more based on your usage. Whereas when you want to upgrade your own one, you have to thoroughly buy a new system or buy a new hard disk to put it in, to plug in, like this. Similarly, like the speed as well, if you want to enhance speed with the cloud, it's very simple. Just add more servers, your speed will be increased. And also for a day-to-day task, your technical staff is not needed for that. Cloud is underpinned by state virtualization technologies, where your technologies can be totally virtualized from their platform. What are the negative? Of course, everything comes with a cost. Whatsoever you are going to take it on, you have to pay it first. So cost depends on CPU power, memory, disk type, capacity, input, output, backup, and other aspects of the service you require for your things based on that. Okay, now in this slide, there is very important two main points which we need to learn. For a virtualization terminology, when we talk about machines hardware on which the virtualization software is running is called the host system. Remember that the hardware where your that software is running is that is known as host system. Virtualization or virtual operating system, your server or desktop are referred to as a guest. So the operating system which you are putting it in, that is a guest, and the hardware which you are using is the host. So virtualization products that run directly on the hardware are described as type 1 virtualization system, which is a bare metal virtualization. And the second type of thing is virtualization products that run on operating system, Windows, Linux, are type 2 virtualization products. For example, the virtual box which you have installed on your systems to do your lab, an example of type 2 virtualization. What is that? You installed a virtual box and put it on a operating system. So remember that your operating system is a guest. Your host was already there. You put a guest system on your machine. Type 1 is the one which is actually provided by the cloud service providers. So here see the example of these two. This is the type 2 one, which is your own computer where you do in the lab. All things are there, CPU, memory, NIC card, disks. This is your host operating system like Windows, and what we have installed, guest operating system, which is Linux. And in Linux, because we have created the virtualization layer by the help of VMware, that VirtualBox software that created that layer of virtualization layer for us. Based on that, we are actually running the guest operating system, which is Linux, and on Linux we are running the applications. So in that way, you can see with one host operating system, there is another guest there. Make sense? So your laptop, your desktop computers, they have host and they have the guest operating system, which is the Linux one, which we have put it in to run it some other stuff. Clear? Whereas for type 1 virtualization, that is more like the services. For example, you are using their virtual lab. Everyone is logging online. Maybe you are using somewhere on the cloud. You are connected with the operating system. Everyone is connected with the operating system and with the app and running on it. Maybe this is run by ATMC, this is run by Fed University, this is run by eBay, this is run by some other company. So in one cloud provider company, they have in one server multiple operating system can be possible. Nowadays, 90% jobs are done by virtualization, with the big companies as well. They have one big server which has the capacity of running, let's say, 64 computers. They create 64 virtual machines in one computer, and sitting somewhere in the world, operating it and making it one as an email server, one as a server of making payments, one as, for example, taking example of eBay. For eBay website, they have one server. Payment gateway, another server. Some other stuff to handle, another server. Database, another server. And those servers are what? They are virtually in one computer, but they are separate. So that's how the cloud things are moving on. Okay. Now moving to the next concept, which is introduction of mobile computing. Okay, read it please. Yeah, you can read it. Yeah. Yes.
Introduction of mobile computing. Mobile is most commonly refers to access in motion and is unrestricted to a given geographic location.
Yeah.
A set of IT technologies, products, services, and operational strategies and
Procedures.
procedures that enables the users to gain access to competition information and related resources and capabilities while mobile. Applications of mobile computing have become
Ubiquitous.
ubiquitous and in business, consumer industry.
Boys, excuse me, please come forward. These chairs. Once we finish the lecture, then you can work it on desktop. Come forward, all of them. Front seats. Okay.
Key advantage of mobile computing is convenience, allowing users anytime and anywhere to access information and computational resources.
Yeah, so mobile computing is more about whatsoever on the mobile phones right now we are using apps. Our all computation is going on live. And we know that with the geographical locations we are moving on. With that one, our apps, processing, all done with that strategies with respect to mobile computing is done by using those softwares which are running on our mobile phone. So all procedures, operational strategies, for example, for Uber, for your apps of Google Maps, they are running online to show you everything when you are moving on. So all strategical information, access to computation, information related going between the computer and between the servers going online. And they also like the services like at our home, at our smart systems, the systems which include your smart devices, okay, IoTs, in Internet of Things. So all things are now more mobile, and computation services are all mobile as well. So the main advantage of mobile computing is what? Anywhere, anytime, you have the access of that, and that's itself is a complete course you will see in your upcoming weeks. Now the next concept is mobile networking. Okay, can you read that? Give to him.
Mobile networking. The mobile phone network is underpinned by many technologies. Those technologies have been in a state of continuous change since mobile phones were first introduced in the 1980s. Their progression in mobile systems is described as differing generations. The first generation 1G, then 2G, 3G, 4G, and 5G into the future.
Yeah, so we can see that now we're looking to the next concept of mobile networking. Mobile itself, as I mentioned, the first evolution started in 1980s, but more it was done in 1990s. So these 1G, 2G is the generations of different mobile phones from different time period. And as we know that it goes up and keep going with more expansion of the resources, facilities, features on those ones. So what are those? First of all, just have a quick look on the how the mobile network works. So in your mobile network, one main concept is known as base station. Another thing in the base station is that there are mobile phones, your mobile equipment, or a mobile phone which is inside that base station. So now my question to you, and the third thing is mobile switching center. So there are three things: mobile equipment, base station, mobile switching center. So these are three components of mobile networking mainly. There are more as well, but I'm not going into detail because definitely in a separate course you will go in more detail on that. So what we are talking about here is why the shape of this one is hexagonal. Anyone idea? Why the shape is hexagonal? No? See, if let's say antenna is placed here and I have a square, let's say this is a square. So if I increase the radiation power of that antenna, so it will go there equally. But of course, when you increase the power, the antenna waves will go there as well, go there as well, go there as well. But it means that it is going outside the boundary. Other thing is if we have a triangle, again this way, this way, this way is equal. But if I want to go again, this amplitude is more again. So this is also a cross. If we make a circle shape, in circle everywhere it's equal. But the problem with the circle is that when more number of different circles are there, there's a gap in between. It means that your mobile phone is in this location with this antenna connected, and you're moving on a train and you are moving there. As soon you come into that area, it dropped the signals because there is no radiations are there. So therefore, in order to cover that thing, hexagonal structure is the best one, which covers, for example, from here everyone is equal. And the second beauty of hexagonal structure is it always covers perfectly with the next one. So you can see there is no spaces. And you know the concept of hexagon is taken from where? How it was conceived by the scientists or engineers? Honeycomb. The honeycomb has the structure without having any spaces. So this is your base station, and in that one, if there is a car going on in the person, and if it's moving from one to another one, always, if it's with the same network like a Vodafone, it will tell to the MSC that this person is moving from this one to this one. It will hand over the call to this one, to that one. So there are 100 of different things are going on at the same time, but mainly you need to remember that, as I mentioned you last time to show you how the base station looks like. So there are three things: mobile equipment. That's why we say our phone a cell, because this is known as a cell, and that's why our phone we say cellular company, cellular mobile phone or something like that. And these cells are actually based on our planning of coverage area. If we are in the more city areas, more congested areas, we make more smaller cells because we need to reuse that frequency for more number of users. But if we are on a area which is hilly areas or more rural areas, our cell size is more bigger because less number of people are there in that area. Itself, this is a complete concept of how we are using the reuse of frequencies. So each cell contains a base station and a radio frequency transmitter and receiver. Of course, when we are making a call, because right now as well, where 10 people are or 15 people are there, if around there in the university there are 200 people let's are there, based on like our mobile phone, it's still connected on. It is keep sending the signals always. I am here, I am here, I am here. That's why when you receive a call, how you receive a call if it doesn't know your location. And that's why it is always keep connected with the base station. So it means that our all phones are connected right now as with the base station as well, with the nearest one. But as we move to the next area, it jumps to the next base station area. But we never feel that it is disconnected because they make in a way of hexagonal structure. But in a real life, remember that when in a real life, waves are not like that. They know that, oh, this hexagonal structure is finished, so I stop. So you actually try to make it like that, but it's a rough sketch of it. When you see actual one, maybe it's like not exact waves, not exact like that, but theoretically it should be like that. So then, of course, if that is from same mobile switching center, it goes to the same network. But if it, let's say, with the Telstra, maybe they say, okay, now send the signal to mobile switching center to this MSE of Telstra. Telstra send to their customers BTS then. So base station control communication with mobile device in itself. Each device uses one radio frequency. For example, for transmission and receiving, as you know, when I'm making a call, my frequency channel is different, and transmitting and receiving on a different channels at the same time. So there are two things we need: transmission and another for reception. So we need one radio frequency, but it has two parts: one for uplink, one for downlink. And as I mentioned, MSE controls the switching of a or transition of a mobile phone as it moves from one cell to another cell. It also controls the interface with, let's say, for the landline numbers, everything it connect with that to, let's say I call to a landline number from mobile phone. So it means that it will go to MSE and then to landline switching center. From there, they know that this number is located there and they switch over to that. So next concept, which is about moving from one cell to another cell, which I mentioned you already. So as you move from one cell to another cell, definitely signal in one cell when you are on the edge is weakened, and then you move to the next one, it's more stronger. So we know that which cell I am going to expect to be there. Based on that, MSE has to make a decision to switch over our call to next cell. Sometime in a very high speed cars or trains, our call drops due to that one as well, because that handover is not done properly. If that handover is done properly, our calls are switched and we never know that because it's already switched from one BTS to another BTS. So it's something like that, like you have a Wi-Fi network of 10 different, let's say this is a flow number 1, 2, 3, 4, 5. You keep moving on every single Wi-Fi network you have the password. So it will keep connecting on with the next to next to next. But that's different because they are separate to each other. But BTS, they are all well connected with the one main source. So they know that this user in this area is moving in that one. That's why the police or agencies, when they want to trace someone from the mobile phone, they can trace where the person is going on with that same. Again, we have always have a set of transmitter and receiver radio frequencies being used by the phone, and all network traffic being directed through the new base station. The change from one cell to the new cell is controlled by the MSC. After transition all network, that's the voice traffic to the phone is directed through the new base station. So new base station has now that new thing is there. Okay, can you read this one now? This slide.
How base stations communicate with access, depending on the technology and the mobile carrier network, the way the base station communicates with the mobile device in the network varies. The three standard access methods are FDMA, frequency division multiple access, TDMA, and CDMA. FDMA and TDMA were discussed as part of the physical layer discussion. CDMA is very interesting digital technique in common use throughout the world. CDMA stands for code division multiple access. In CDMA, each device has unique code called chipping method.
Chipping code.
Chipping code. That code is combined with each bit for transmission. The data multiple devices is also combined and sent as one transmission. The receiving station uses the
It's chipping code.
code to decode this data. CDMA will be investigated during this week lab session.
Yeah, so now the thing is how base station communicate with handsets. We already learned about TDMA or FDMA, how we allocate the resources between the users. CDMA is another way to do the same thing as well. So we will see what is the CDMA, which includes a chipping code, and for each bit of a transmission, it combines and it's sent over the wires or on a wireless media, and on the receiving end, we can again decode its data. We will see this example soon after finishing these slides. Now coming to the technology summary point, like with the technology of mobile phones, we start from 1G network, which is analog and supported only voice. 2G having a GSM with the voice with a small including of MMS. 2.5G includes with that one, as I mentioned, SMS is there as well, MMS is there as well. 3G includes your then CDMA technologies, which are WCDMA, TDC, SDMA, and the 4G are more IP based technologies, and they are actually have wide range of frequency which allow smooth transition from many mobile carriers. So you can see now in our mobile phones, before that it was not like that, because they are now on IP based LTE, long term evolution, or the 5G network, which are all IP based. Before that it was more like a network based, simple mobile based. There is no IP based, there is more like a circuit switching. So what is the difference? For example, like when you by using internet connection, when you using WhatsApp, you know that someone is when typing, it's written typing on. The same thing is now happening in our local normal phones as well. We can see dots are coming when someone is writing. Before that it was not there, we never know that, because now they are also switched to the IP network based. Before that it was not like that. So their architecture is also now updated. So upcoming years everything will be on IP based, and almost it's there, almost it is already done. And the other thing is, which is important, is like with the generations progression we are looking, mainly the thing is the data rate. With every single thing on that, their data rate keeps increasing on that. And also there are some different type of features they are using. For example, for a 1G they are using circuit switching, FDMA, voice only, analog communication on that, and the signals you can see only 30 kilohertz. On 2G 1.8 digital, 3G 1.6220, 2 to 8 gigahertz. Because you remember that when bandwidth increases, the percentage of, let's say the percentage of 10% is percentage of 10% of this, 10% of this, 10% of this is also like, if we are using for that 10%, the value for this one is much more than this. When something in gigahertz you take 10%, and something you take a in kilohertz 10%, is different. It looks like the same, because we are, if you say like in numbers, that more easier. Like if one number is in thousands, you take 10%, and one number in millions 10%. Both are different. So it means that in millions of 10% is much more capacity than 10% of thousands, and that's how their data rate increases. And in that one you can see it is packet switching, which is kind of a internet one. And they are using CDMA, higher speed, 100 megahertz band with the LTE and WiMAX and other standards. So here we are just going to see the basic touch of those all technologies, how they are there. Because as a network engineer, you should be well equipped with all those knowledge. Remember that we are not in the basic degrees going in depth of everything, but the knowledge of everything is really important to connect the dots for in your future. Like for example, when you're doing any degree, any job, maybe you're not using every single course in that, but eventually it's important that you have the basic knowledge of everything. So in the remaining 3 weeks, we will cover this security, information and cyber security, cryptography, and also review of our semester material in week 12. So before finishing now, the concept of CDMA, I want to explain it quickly, which is a main part in your today's lab as well. So if you go to week 9, I will just explain you this video. Open your notebooks. Open your notebooks. Okay, guys, have a look. In the CDMA, what we are using is, like, there are 3 different user 1, user 2, user 3 data is there combined together in the form of a code, and on the receiving end we get it back, we decode it and get back the user 1, user 2, user 3 data back, because this is the area where we are transmitting in the wires. So but how we are going to send it by using CDMA? Let's have a look, because this is one of the main example of your lab session as well, and also there is one question usually come in the final exams as well. So have a quick look. So let's say you have a user 1 who has a data of 00. Can you write it down, please? It will very much make it easy for you if you do it by your hand. Otherwise, it will be so confusing for you after when you're doing it yourself. So user 1 data is 00. Spreading code is what? 0101. Now what we need to do is write a code like this way. So you can see that from here, very important point. You need to repeat the point. For example, your spreading code is 0101. First write your spreading code 0101. Your data is this one. What we are doing is we are making a copy of your data times 4. So this 0 times 4, 0, 0, 0, 0. This 0 times 4, 0, 0, 0. Got it? So by using that 4-bit, we are making it 8-bit of data. XOR it. XOR means when it's same, 0, when it's different, 1. So 0101, 0101, this is your user 1's spread code information. So this is your user 1 spread message. You spread the message. Okay? That video is there already. That's okay. Just have a quick look and then you can see by yourself later on as well when you're doing lab. This is your user 1 spread message. Similarly, you have user 2 now, which is 10. So remember that in 10, what is happening? 0, see your spread code is given to you, which is 0011, 0011, and your data is 10. So instead of 1, we write 4 ones, 1, 1, 1, 1, and 0, 4 zeros, 0, 0, 0, 0. Got it? That was the bit tricky part which you need to remember that. Like this 1 means 4 ones, this 0 means 4 zeros. Then XOR again, same thing. So you get a spread message for user 2. Similarly for user 3, that's a more simpler one, which is 1 1 with 0 0 0 0 0. So you all get 1 1 1 1 1. Okay. Now you have all 3 signals available. What you need to do is write the form like this way: user 1, user 2, user 3. Make in a line like that, so you know that they are bit by bit. You need to add them. But remember that for 0 we take it as a +1. For 1, take it as a -1. Because 0 we can't take it as a 0. Because if you take it as 0, that value will be not counted. Their weightage will be not counted. Because if the weightage is not counted, then whenever it add to some number or multiply, it zeros everything. It's a value. Okay, that's why we make it either +1 or -1. So +1 is the 0 equal to, and -1 is equal to 1. So that's why we make it like that: 0 -1, 0 is equal to 1, -1, 0, -1. Got it? For user 2, we already have the value. We make it like that: minus 1 is what? -1, and 4 zeros +1, and then for the third one, straight line. Once you've done that, you need to combine them. Combined waveform is known as composite waveform. How to combine them? simply looking toward first bit, second bit, third bit in this row, add them. See, this 1 to user 1, user 2, user 3, when you add them, it is on -1. When you add this one, that is -3. When you add this one, that's +1. That's -1. That's +1. That's how it goes on. You can see how it is. So your combined waveform is already made. Now that combined waveform is actually traveling over the network, internet, on the layer. On the receiving side, when it read that waveform, what you will do, you have, now this is user 1 data you already have. This is your combined waveform which we already made it from that. So what we do is writing that again, that waveform, and user 1 we know that 0 is for +1, 1 is for -1, and user code was what? 0101. Okay? And what we do for 0101, we make the waveforms for the user 1 code. Okay? And then we need to multiply them. When we multiply them, this one and this one, we get -1. Multiply this one with this, we get +3. This one with this, +1. This one with this, +1. Now add them together. Answer is 4. Keep remember that in the start what we did, 1 0 was equal to 4 zeros. Therefore, at the end of this job, after multiply, we have to do the division. So take the impact of that taken off on the receiver side. So what we do, 4 divided by 4, 1. Next 4 bits, multiply them, add them. Luckily we get 4 again. 4 by 4, 1. It means that the receiving side we get the 1 1 back. For that user 1, that 1 1 is, we get it back. Similarly, for user 2, do multiplication, you will get the back. And for that thing, we already have a, let me show you. Yeah, this one, or we have this spreadsheet is there. So this spreadsheet is already, you can draw it there as well, lines. But once it's better to do it by your hand first. So you get well understanding of that, what is mean by that. So you can see that user 1 is 0101 and user 1 data is 00. This is user 2 data, this is user 3 data. So you please do that example here today, so it stick in your mind, because remember that one question usually come from there. Otherwise, if you don't get the concept here, later on no one will come to teach you again. And I think by week 9 you understand that in Australia tomorrow never comes. Now it making sense what I have said you in the very first lecture. So please do your stuff when you are in the lab, finish it. So this is one part of your lab. Second part of your lab is on the lab sheet, which is a very easy one, part 1. Like a cloud file storage, you're already using a Dropbox or a OneDrive. You open it, that OneDrive in your Windows, and then open the same one in the virtual machine to access the data. That's all. There is nothing very tough thing in that. And take the image of that, because you need to make the files of week 6, yeah, something like that, 6, 5, 6, 9, 11. Yes, those ones to submit it by the end of week 11 or 12. Last thing regarding your network planning assignment, please guys, you have to work it on that. There is a very less time remaining, and if you have any questions on that, we will discuss on that as well. One by one you can ask me. If you stuck somewhere, you have questions, we can discuss about the network planning assignment as well. That's all for our today's lecture and the lab explanation. Any questions? And for your midterm test, I will I'm keep coming checking it, and you will get the marks soon on that. Okay, very good. Close this one.